This is a video from section 12.3 in a Calculus 3 class. The directions say to find the scalar and vector projections of B onto A. The scalar projection of B onto A is the dot product of A and B divided by the magnitude of A. And we're going to label this scalar projection the component of B onto A. That's what that symbol represents. And the vector projection of B onto A is the dot product of A and B divided by the magnitude of A squared, and we're going to take that scalar and multiply by vector A. And we label the vector projection of B onto A as the projection of B onto A. So PROJ is just short for projection. And this is going to represent a vector right here. And with that, let's take a look at an example. So let's take a look at number 39. And suppose A is the vector -5, 12. And B is the vector 4, 6. Now, we're going to need the dot product of A and B. So let's go ahead and just calculate that right now. The dot product of A and B is -5 times 4 plus 12 times 6. But this is -20 plus 72, which is equal to 52. We're also going to need the magnitude of A. So we might as well calculate that as well. So the magnitude of A is the square root of -5 squared plus 12 squared. But this is the square root of 25 plus 144, right? And so coming over here, this says the magnitude of A is the square root of 169, and that's equal to 13. It's real systematic from here, and it's, in fact, really straightforward from here. Because if I want the component of B onto A, that's the scalar projection. And so this is the dot product of A and B divided by the magnitude of A. And if we look back, we did the hard work. The dot product of A and B is 52. The magnitude of A is 13. So this is 52 divided by 13. I get 4. And then if I want the vector projection of B onto A, well, I did that hard work too. And so this is the dot product of A and B divided by the magnitude of A squared, right? And then I'm going to take that scalar times A. Well, this is 52 divided by 13 squared times the vector -5, 12. Okay. Now, we can write this as 4 over 13 times -5, 12. And then I'm going to go one last step here. And so I'm going to say the projection of B onto A is equal to, I'm going to take, the first component is -20 13ths. The second component, right, is 4 times 12 is 48, right? So I get 48/13. And in a nutshell, that's how we do problem number 39. Let's take a look at 41. Suppose A is the vector 4, 7, -4. And B is the vector 3, -1, 1. Okay. Now, same directions, right? We want the dot product of A and B first, right? It's a nice systematic way to approach this. So I get 4 times 3 plus 7 times -1 plus -4 times 1. But this is 12 minus 7 minus 4. I get 1 back. The magnitude of A, this is the square root of, give myself room, and it's 4 squared plus 7 squared plus -4 squared. So this is the square root of 16 plus 49 plus 16. And this is the square root of 81, which is 9. So I'm in good shape here, because now the scalar projection of B onto A, right? And I write it this way, is the dot product of A and B divided by the magnitude of A. But I did the hard work, right? Because the dot product of A and B is 1. The magnitude of A is 9. I'm done. The projection of B onto A is the dot product of A and B divided by the magnitude of A squared. And I'm going to take that scalar times A. So this is 1 over 9 to the second times the vector. And for 41, A is 4, 7, -4. And so again, this is 9, right? And remember, 9 squared is 81. And so, therefore, the vector projection of B onto A is going to look like. And it's going to be 4 over 81, 7 over 81, -4 over 81. That's how we do number 41. Let's take a look at 43 for the last one in this video. Suppose A is the vector 3i minus 3j plus 1k. I put the 1 in for emphasis, all right? And B is the vector 2i plus 4j minus 1k. And I want the dot product of A and B. Well, what do you get? You get 3 times 2 plus -3 times 4 plus 1 times -1. So this is 6 minus 12 minus 1 I get -7. Okay. And then the magnitude of A. Well, so this is the square root of. We take it one at a time. So I take 3 squared plus -3 squared plus 1 squared. It's the square root of the sums of the squares. And so when I simplify that, I get the square root of 9 plus 9 plus 1, and that looks like it's the square root of 19. So the scalar projection of B onto A, that's the dot product of A and B divided by the magnitude of A. Now let's remind ourselves, the dot product of A and B is -7. And then the magnitude of A is the square root of 19. Okay? And then if I want the projection, the vector projection of B onto A. So this is the dot product of A and B divided by the magnitude of A squared. And remember, I'm going to take that scalar and multiply it by vector A. So this is -7 over 19. And then I'm going to multiply by vector A. And if we remember, A is 3i minus 3j plus 1k. And if I go to simplify that, the vector projection of B onto A is, and so this is -21 over 19i plus 21 over 19j minus 7 over 19k. And that will conclude this video for section 12.3. And in this video, we looked at problems 31, 41, and 43. Okay, thank you.